Welcome to Friendly Math 101. Today's lesson is over triangle similarity. So there are three ways to determine if triangles are similar, and these are actually missing something on their names. We have angle-angle similarity, side-side-side similarity, and side-angle-side similarity. So starting with angle-angle similarity, I will just draw an example. So we have two triangles. If two of their angles are congruent, then that tells me we have angle-angle similarity. These triangles are going to be similar. Then we have side-side-side similarity. So if I have two triangles, and these triangles have proportional sides, then I have side-side-side similarity. So if this was like 2, 4, 6, and this triangle here was half of each side, so this was 1, 2, and 3, this would be side-side-side similarity because all their proportions are equal. 1 over 2 equals 2 over 4 equals 3 over 6. So the sides are proportional, then you have side-side-side similarity. Then we have side-angle side similarity. So let me draw my triangles here. Notice how the angle is in the middle of the sides, which means wherever your angle has to be congruent. Wherever your angle is, you have to look at the sides that meet to form the angle. So if this side was 6 and this was 6, and this side was 10, this side would also have to be 10. They have to be proportionate. These sides don't have to be equal, but they do need to be proportionate. If you had, say, this side and this side were proportionate, that would not be side-angle side because the two sides have to include the angle. The angle has to be in the middle of the two sides. So this would be congruent, and this might be confusing. So let me change the numbers a little bit. If that was 6, this is 12, and this is 8, that's 16. Those sides are proportionate because I'm just multiplying by 2 to each one. The angles are congruent. That's side-angle side similarity. Let's get started on some examples. We're going to determine if they're similar. If they are, we'll give the reason, and then we'll try to determine the corresponding parts of the triangle by naming it. So if we look at our first example, let's look at the triangles that we have. We have this big triangle, ABC. So I'm going to call triangle ABC. We also have this little triangle, which is triangle DBE. I'm not naming that in any particular order. I'm just going by what I see. Now let's determine if these are similar. First of all, we're given one angle is similar. So E and C are congruent. Since E and C are congruent, if we have another angle that's congruent, we could use angle-angle. Well, if you notice, this angle B here is equal to itself. Both triangles use angle B. Angle B equals angle B, so we have similarity by angle-angle similarity. And actually how I wrote them here is how they're going to be written down here. Triangle ABC is congruent to DBE. We know that because E and C are corresponding, so they have to be in the same place. B and B are corresponding, so they have to be in the same place as well. And so A and D would end up being at the front of how I wrote it here. Moving on to our next example. Okay, again, we're going to do the same thing. Figure out if they're similar, give a reason, and then name them with corresponding parts. Now, I see here I have an angle. They're equal. That's good. And I have sides. So this could be a side angle side similarity, but we have to determine if these proportions are equal. So for this triangle to this one, I have 10 over 5. Okay, that, if I reduce it, equals 2. So if I take side DF to AC, 15 over 10, that also needs to equal 2 for these to be similar triangles. Well, 15 over 10 is actually 1.5, so that is not equal, which means these are not similar triangles. If this proportion happened to equal 2, then that would give me side angle side similarity, but it doesn't. Okay, so let's move on to our last example here. Okay, so again, let's talk about our triangles here. So I have a triangle ABC, and I have this triangle DEB. We don't know any order yet, but we know these are our triangle names. Now I see I have C and D are corresponding. C and D are corresponding. So if these do end up being similar, my D would have to go where my C is here, since they are congruent. I have sides that include the angle, which means if these are proportionate to each other, I could have side angle side similarity. So now let's determine if these are proportionate. So I'm going to go ahead and label my triangle how it would be. B and B are should be in the same position, and then so I'm left with E here. So EBD is congruent to ABC. Now we need to look at if these are actually similar. So let's look at their proportions. So AC, if I look at AC here, that's going to correspond to ED. So that's going to be 14 over 7. That equals 2. Now let's do the same thing with the other corresponding sides. We have CB, or BC, that's going to be corresponding to BD here. So 16 over 8 also equals 2. That's good. That means these are similar. The reason being side angle side similarity. And again, I already wrote out what they should be. So it's triangle ABC is similar to triangle EBD. Thank you for watching, and for more math tutorials, please subscribe to our channel, Friendly Math 101.